Welcome back, my dear students. Today we are going to uncover the secrets behind how birds fly so efficiently in the sky. From the shape of their feathers and wings to the amazing principles of aerodynamics that help them lift off, glide, and soar, we will break all down step by step. So stay with me till the end. Let's explore how birds conquer the skies together. Birds can fly not just because of their feathers but because their whole bodies are designed for flight, with powerful chest muscles that can make up over a quarter of their body weight and an incredibly lightweight build. Their bones are hollow, they digest food quickly, and they have no heavy jaws or teeth, making them much lighter than they appear. Even a digest food quickly, they appear. Even a tiny bird like the Japanese white eye weighs just 10 grams. Now we should discuss the key terms in flight aerodynamics. First one is the angle of attack. In fluid dynamics, the angle of attack is the angle between a reference line on a body like a wing and the direction of the oncoming airflow. A small angle lets air flow smoothly over the wing, helping to create lift. Aspect ratio. The aspect ratio of a wing is the ratio of its length or span to its width, that is means chord. A long narrow wing has the high aspect ratio and short wide wing has low aspect ratio. Wing loading. Wing loading is the bird's weight divided by its wing area. Lower wing loading helps birds fly with less effort. Camber. Camber is the curved surface of a wing's cross section. A cambered wing has a convex curved out upper surface and concave curved in lower surface. This shape helps create lift by changing air pressure around the wing. Drag. Drag is the force that resists movement through air. Parasitic drag, the drag on all parts except the wing tips. Induced drag, the drag caused by air swirling at the wing tips due to pressure differences above and below the wing. Parasitic drag increases with speed. Induced drag is higher when lift is highest, usually at low speed. Yaw, roll and pitch. Yaw is the turning left or right around the vertical axis due to pressure differences on the sides. Roll, rotating around the body's length or longitudinal axis due to pressure differences between head and tail. Pitch, tilting up or down in the horizontal plane due to uneven wing flapping, that is the pitch. The first image in this diagram shows the main types of bird flight feathers and how they fold. Primary feathers are outer wing feathers. The shaft are curves, the sides are uneven, they are used for thrust. Secondary feathers are inner wing feathers. Their shaft are also curves, sides are equal, used for lift. Tertiary feathers are shorter feathers near the body. They cover and protect inner feathers. And folded wings. Primaries fold close to the body, making wings compact when resting. The second image shows a bird's wing with a feather highlighted. The feather has a straight shaft and the weight of both sides is roughly equal, indicating it is balanced inner wing feather, likely a secondary or a tertiary feather used mainly for lift. The last image shows a comparison between a secondary feather and a tail feather. The secondary feather left is slightly curved with equal sides, used for lift on the wing. The tail feather right side is straighter and stiffer, helping with steering and balancing during flight. Now study basic principles of flight. To fly forward, a bird must produce enough lift to balance or exceed its body weight. It produces enough thrust to overcome drag. What is Bernoulli's principle? Direction of flight. This is the high velocity airflow, lift due to pressure differences. This is the low pressure area, low velocity air pressure and high pressure. So how lift works? Wings are tilted at an angle, that is angle of attack. Air flows faster over the curved top on the wing than under it. By Bernoulli's principle, faster airflow means lower pressure above the wing, This pressure difference pushes the birds upwards. This forces is lift. How thrust works: wings move to push air backwards, propelling the bird forward. If lift is greater than bird's weight and thrust is greater than drag, the bird can rise and move forward smoothly. Bird flight is an amazing balance of physics, wing design, and body structure. Every phase from takeoff to landing is perfectly adapted for safe and efficient flying. Mechanism of bird flight. The flight of birds may look simple. They lift their bodies and move forward by beating their wings, but in reality it involves many complex and precise steps. The aerodynamics behind this can be explained by Bernoulli's principle. Bernoulli's principle was proposed by Swiss mathematician Daniel Bernoulli in 1738. It states that the pressure of a fluid like air is inversely proportional to its velocity. This means faster moving air has lower pressure. This principle helps explain how birds generate lift. Phases of bird flight. A bird's flight has different phases, each with its own special actions. Number 1 is takeoff. Takeoff মানে উপরে উঠে যাওয়া. The first step where the bird leaves the ground or a perch. The bird must build enough forward speed to create lift. Small birds, which are lightweight, they often jump suddenly to gain momentum. But large birds like eagles or vultures, they run and jump to reach the needed speed. Aquatic birds use wing beats on water and air currents to build momentum. Lift. Once airborne, birds use lift to stay up and rise higher. Lift balances their body weight and gravity. Forward propulsion and gliding. Birds flap their wings in a rapid screw-like motion to push air downwards and generate lift and thrust. The wing beat cycle includes effective stroke, pushes air down, and power stroke provides the thrust. Large birds are often glide over flapping. While gliding, they slowly lose lift and sink, so they flap again to gain height and glide once more. Stability and maneuverability. If the bird's body tilts or drifts, aerodynamic forces can push it further of course. Birds make quick maneuvers like loops or rolls to adjust. To correct roll, increase the angle and surface area of the lower wing to raise lift on that side. To fix yaw, open, twist the tail feathers or rectrices and adjust one's wing angle. To adjust pitch, move wings forward to balance the front, bend the tail upward to help tilt. Turning. While turning, birds increase lift and wing loading. Small birds turn quickly due to lighter weight, but large birds turn more slowly. Sinks and descending. When birds want to descend, they adjust the wing angle and area to reduce drag and maintain enough lift to control their glide. Braking. For a smooth landing, birds must slow down or brake. They reduce the lift to drag ratio by changing angle of attack, wing area, wing camber or curvature. Landing. The final phase where the bird's feet touch the ground or a perch. Landing causes strong forces on the legs. Birds have collagen tendons in their feet to absorb shock. Their hip structure helps shift landing forces from the ball and socket joint to the ilium or hip bone to protect their legs and joints. Chief modes of flight in birds. Birds use basically four main types of flight, and the same bird can switch between them depending on its needs. Birds are amazing flyers. They can glide, flap, soar or hover using different flight modes to suit their size, shape and need. Gliding or skimming. What it is? The simplest form of flight. After flapping their wings to gain speed, birds hold their wings outstretched and glide forward without flapping. Without flapping they fly. This is gliding or skimming. Coasting downhill on a bicycle using a momentum like this way. The key points for gliding: wings must firmly brace to the body. elbow and wrist joints must stay rigid. The wings must have a firm leading edge facing the airflow. Birds must flap occasionally to regain momentum or they will lose height. Examples: gulls gliding in circles over a moving ship looking for fish or food scraps. Now we study flapping flight. What it is? The most common bird flight, like a swimming breast stroke in the air. How it works? Wings move up and forward, the down and back in a cycle. The upstroke is quick. Wings partly fold to reduce resistance. The downstroke or power stroke pushes air backward and downward. The wing tips tilt upward to help lift and thrust. Before the upstroke, the elbow bends and the wings partly fold. Examples: ducks, crows, sparrows, and most small and medium birds wing beats. Small birds flap faster. Sparrow flap about 13 times per second. Larger birds like pelican flap is 1 to 1.5 times per second. Special note: birds with long pointed wings like swifts, falcon, pigeons are strong, sustained flyers suited for their long journeys. Soaring flight. What is it? The most specialized and spectacular type of flight. It is seen in vulture, hawks, gulls, pelicans, falcons, storks and albatrosses. How it works? Soaring has two phases. Circling phase, the birds flies in circles or loops, gradually gaining weight, and gliding phase, the birds glide forward using rising warm air currents or thermals. Wing position: wings are fully extended, the primary feather tips spread wide. Key principles: soaring flight. Soaring usually begins when sunshine creates warm air currents. Birds with higher wing loading, heavier per wing area, soar at greater heights. Larger birds circle in bigger loops during soaring. Hovering flight. What is it? The birds remain almost motionless in the air or by rapidly beating its wings. How it works? The body stays vertical and still. The wings beat downwards and forwards on the downstroke and backwards and upwards on the upstroke. The wing tips move in a figure of 8 pattern like a helicopter's propeller blades, best seen in hummingbirds like perfect hoverers. In India, pied kingfisher, kestrel, black-winged kite, fishing eagles to some extent. So today we explored how birds fly, from the principles of aerodynamics to the shape of their wings and feathers and the forces that lift them into the sky. If you found this lesson helpful, don't forget to like, share and subscribe for more easy explanations. Keep wondering, keep learning. See you next time. Thank you.